Hey, we're coming to a close in our videos for chapter 9, which is a good thing. So now what we're going to talk about is one proportion testing in the calculator. So let me bring up my calculator and let me show you. Oops, that's not it again. Ugh, having difficulty today. All right, so turn it on. And this one's a little bit trickier to find, but you're not going to have to put any data in. That's the great thing. So go to stats. Oh, come on, calculator. And go over to test. This one is down at number 5, one proportion z-test. So hit enter. Okay, so PO is the percentage given in the problem. It's the percentage used in the hypotheses. X is the proportion of the sample affected by the percentage. N is your sample size. And this is going to be your sign that you use in your alternative. So the output you get is the first line will be the alternative hypothesis. The Z is the Z-test statistic. The P is the p-value. But don't get that confused with p hat, which is X over N, and N is your sample size. So the best way to see these is just to do one, okay? So June believes that 50% of first-time brides in the U.S. are younger than their grooms. She performs a hypothesis test to determine if the percentage is the same or different from 50%. June samples 100 first-time brides, and 53 reply that they are younger than their grooms. For the hypothesis test, she's using a 1% level of significance. Okay, so let's go ahead and look at it. So, is this a test for a mean or a proportion? Well, it's a proportion because it doesn't talk anything about means, and it actually has percentages in it. So the next step, state the null and alternative hypothesis. Well, remember if I go back to the problem, so I'm looking to see that the percentage is different or equal to 50%. Well, that tells me that for my hypothesis, I'm just looking for a, does it equal or does it not equal? With these percentages, you need to make them decimals, so all you do is drop the percentage sign and move the decimal 2 places to the left. So my null hypothesis is P equals 0.5. My alternative is P does not equal 0.5. So is this a right-tailed, left-tailed, or two-tailed? It's a two-tailed, and the hint is the not equal sign in the alternative. So what symbol represents the variable for this test? And it's a capital P with a little comma at the top. In other words, define the random variable for the test. It's the percentage of first-time brides younger than their grooms. Okay, so let's calculate the following. X equals the 53. It's the number of brides younger than their grooms. Lowercase p with that little, I guess, comma in the air, apostrophe. I guess that's what it is. X over N is 53 over 100, which is 0.53. We're going to get that later when we put this in the calculator. And then N is your sample size. So which test should we use? Since no mean was mentioned, we use the estimated proportion distribution because it's got all these percentages in it and no mean, so it's kind of an easier one to pick. So below you see the distribution, and it's P apostrophe tilde normal, where the mean is just the P, comma, and then the standard deviation is the square root of P times Q over N. So what is P times Q? So P is the percentage you're using in the hypotheses. Q is 1 minus P. So for this one, it's 0.50 because both of the P and the Q together have to add up to be 1 because you're taking into account all the percentages. It goes back to that binomial distribution we talked about earlier. Okay, so let's put this in the calculator and see what we get. Just a second. I'm going to change something. Okay, so here I go. So I'm going to my calculator. I'm going to go to on. Okay, so here I am. So remember I said this was 0.50. My X was 53. And my N was 100. And this was not a directional test. It was just, they just wanted to see if it was different. So I hit calculator and boom. Okay, so you can see here I have my p-value, which is 0.5485. So what does that tell me? It tells me that my p is greater than my level of significance because 0.5485 is greater than 0.01. My decision then, because it's greater, is I fail to reject my null. Why? Because my p is greater than my alpha. So at the 5% level of significance, there is not sufficient evidence to conclude that the percentage of first-time brides who are younger than their groom is different from 50%. Because what we're really seeing is if we fail to reject the null is it equals 50%. So that's the way that you conclude that. And we've done these in a couple of other ones. So basically the formula is if you're failing to reject that null, there's not enough evidence to support your alternative. And that's how you kind of should think about it. I hope this helped.